Okay, the first molecule that we have drawn in the class is CH4, methane molecule. Okay, the Lewis structure for the methane was like this. Okay, so how many domains do we have here? One, two, three, four domains we have here. Okay, so the number of domain is 4. The hybridization would be sp3, and you know, for the sp3 hybridization, the electronic geometry is tetrahedral, and we have molecular geometry as well. The molecular geometry for this one is also tetrahedral. When you don't have any lone pair on the central atom, the electronic geometry and the molecular geometry are the same. But if you have a lone pair on the central atom, they would be different. So I will explain later what is the difference between electronic geometry and the molecular geometry. So how is the shape of these molecules actually? I want to show it here. So you have four domains. Okay, this is the shape of the molecule. Okay, you can see the molecular geometry is tetrahedral, electronic geometry is also tetrahedral. So I can rotate the molecules, so you can see it's three-dimensional molecule. It's not only one dimension. So look at this bond that you have here. It's coming out of the board. This one goes inside the board. So if I rotate it carefully, these two is on the surface or on the screen. So this one is coming out of a screen, this one goes into the screen. Okay, so how you draw that one? Let's go here and I will show you how you have to draw the tetrahedral arrangement. Okay, this is the tetrahedral arrangement that we have. So what do we have here? You have the carbon here. This bond is on the board, so you write H here. This one is coming out, so you show it by the bold line here. This one which is going inside, the bond we show it shaded. This one it is on the surface, so we show it by the solid line. So you have H here, H here, H here. So this is the shape of the molecule, and the angle that you have here is 109.5 degrees. So this is how you have to draw your molecule. So let's go back to here. Okay, so if you want to draw the tetrahedral arrangement, draw the central atom. You have four domains, one at the top on the surface or a screen. The other one is here. One bond is here, is coming out, and one domain or bond is going inside. And you have H, 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 H. Okay, and the angle between all of them is 109.5 degrees. Okay, let's go to the next molecule. The next molecule is NH3. The Lewis structure for that is like this. So the number of domain that we have here. Okay, so we have 1, 2, 3 bonds around it, plus you have one lone pair here, so plus 1. So the number of domain is 4. When the domain is 4, the hybridization is sp3. So the electronic geometry, I show it by EG, so I don't write electronic geometry every time. So electronic geometry, when the hybridization is sp3 or when you have 4 domain, is tetrahedral. But what is the molecular geometry, or what is the shape of the molecule here? Okay. So the shape of the molecule would be different in this case from the electronic geometry, because I said if you have the lone pair, then the molecular geometry and electronic geometry are not same. So look at the molecule that you have here. You have 4 domains here. You can see here 1, 2, 3, 4. But in the fourth one, you don't have any bond. What do you have here? You have a lone pair. So we don't count it when we want to determine the geometry of the molecule or the shape of the molecule. So you have nitrogen here, single bond hydrogen. This one is coming out of the plane, hydrogen, and this one is going inside. So it becomes H. So this would be the shape of the molecule. Okay. So the shape of the molecule is trigonal pyramidal. You can see it's like the pyramid. Okay, look, this is pyramid that you have here. So that's why we call it pyramidal structure. So when you have one lone pair in tetrahedral or in four domains, the shape of the molecule would be trigonal pyramidal. Okay. So how you have to draw this one? Okay, the drawing is the same. So you have four domains. I draw the four domains for now. These are the four domains that you have. Here you have hydrogen. Here you have hydrogen. Here you have hydrogen. But what about this domain? In this domain, you have a lone pair. So I don't need to draw that one. Okay, so here I have the lone pair. So this is the shape of the molecule, which is trigonal pyramidal. The angle here, it was 109.5, but because you have a lone pair here, the repulsion between the lone pair and bonding pair is more than the repulsion that you have between the bonding electrons. So that makes these bonds closer to each other. So in that case, the angle decreases to around 107 degrees. So the angle here is smaller when the shape of the molecule is trigonal pyramidal compared to when the shape of the molecule is tetrahedral. It decreased to 107, and I can show it here. So here you have three bonds and one lone pair. So this would be the shape of your molecule. Okay, so you can see it's like the pyramid. Okay, this one is clearly shows how it's like the pyramid structure. Okay, so let's move on. Go to the next molecule that we want to draw. The next molecule is water molecule, H2O. The Lewis structure for H2O is like this. So you have oxygen with two lone pairs on that, and it bonds to two hydrogens. So what is the domain here? You have two bonds, one here, another one here. So we have two bonds plus, and we have two lone pairs on the central atom. So 2 plus 2 becomes sp, or sorry, the domain becomes 4. So when the domain is 4, the hybridization is sp3. And for the sp3 hybridization, the electronic geometry is tetrahedral. Okay, and for tetrahedral arrangement, when we want to draw the molecule, you have one domain at the top, one domain here. Both of them are on the screen. One domain is coming out of the screen, one domain is going here. But molecular geometry is different from the electronic geometry. Two of them are bonds, so you can draw the bond in any of these domains that you want. I prefer to draw one bond here, H, one bond in this domain, H. What about these two domains that we have here? There are lone pairs inside it. So here I delete this one, I put a lone pair. So this would be the shape of the molecule. How is the molecule? The molecule is bent. Okay, and the angle again, it decreases from 107 because you have two lone pairs, and the repulsion between these lone pairs and bonding pair is more than the repulsion that you have between the bonding and bonding, and the angle decreased to approximately 105 degrees. So here the shape of the molecule would be bent. Okay, let me show you on here. So this is the structure, and it clearly shows why it's a bent molecule. So here you have oxygen in one domain, have bonds with hydrogen. In another domain, it has the bond with hydrogen, and you have two lone pairs here, which it doesn't make any difference, or it doesn't count when we are talking about the shape of the molecule or the molecular geometry. So the molecular geometry is the bent. The molecule is like this. Okay, so it's bent, and the angle here decreased to 105 degrees. Okay, also I can show here in three-dimensional you have two bonds, two lone pairs, so you have four domains, but the shape of the molecule is bent. Okay, so you can see this is your molecule, it's bent. Okay, it clearly shows that it's bent molecule. Okay, because in the molecular geometry we don't count the lone pair. I cannot show the lone pair, so if I don't show the lone pair, you can see that the molecule is bent, but they are actually available there. Okay, so let's move on and let's go to the Lewis structures that we had. Okay, the next Lewis structure that we have drawn in the class is H2CO. Okay, let me change the color of my pen. Okay, so the Lewis structure was like this. Okay, so how many domains do we have here? This is 1, this is 2, and 3 domain. Okay, so we have 3 domains here, 2 single bond, 1 double bond. We don't have any lone pair on the central atom, so plus 0. We have 3 domains. For 3 domains, the hybridization is sp2, and for sp2 hybridization, as we said earlier, the electronic geometry is trigonal planar. Because we don't have any lone pair on the central atom, the molecular geometry also is trigonal planar. And how we draw trigonal planar? Okay, so I have central atom, one domain at the top, one domain here, one domain here. So it's like the Mercedes-Benz logo. Okay, but in this case, these domains is the double bond, the oxygen, hydrogen, hydrogen. And what is the angle when the arrangement is trigonal planar? Yeah, the bond angle is 120 degrees. Again, I can show you here how is that molecule. Okay, so this is your molecule. You have carbon here, double bond with the oxygen, single bond with the hydrogen, and single bond with the hydrogen. So your molecule will be C, double bond O, H, H, and all of these domains are on the single plane. I can show you here. So if you have 3 domains, okay, so these are the 3 domains that we have. So you can see the molecule is planar. Okay, so I can drag this one to see how the molecule can be planar. Okay, so look at this one. Okay, so it clearly shows that all of them are on the single plane. Okay, so none of them is coming out up or down. So this arrangement is planar and it's trigonal planar. So when you don't have the lone pair, the molecular geometry same as electronic geometry. Let's go to the next molecule, HCN. Okay, so let's draw that one. Let's go back to this page where we were drawing all these structures. Okay, so we have HCN. Okay, the Lewis structure for that was like this. Okay, so how many domains do we have here in this case? Yes, we have one domain here without any lone pair on the central atom. So you have 2 domains, no lone pair. So the domain is 2. When the domain is 2, the hybridization is sp. Okay, so for the sp hybridization, the electronic geometry is linear, and molecular geometry or shape of the molecule is linear as well. We don't have the lone pair, so they are same. You have central atom. For Linear geometry, you just need to draw two domains opposite to each other, 100 degrees relative to each other. But in this case, one of the domain is triple bond the nitrogen, the other one with the hydrogen. So what is the angle? Yeah, they are exactly opposite to each other. So the angle is 180 degrees. Again, I can show you this one on these pictures that I have here. So when the domain is 2, like this case, you have carbon, triple bond, nitrogen, single bond, hydrogen. So they are exactly opposite to each other. So they are linear. Okay, your molecule is like this: hydrogen, carbon, nitrogen. You can see it's linear. Okay, so that's why we call it linear. And I can show you the three-dimensional structure for that. So you have two domains, one triple bond, one single bond, and you can see that the molecule is linear. Okay. So I can rotate it. So you can see here exactly the molecule is linear. You can see here pretty well here in this case.